This is section 1.8b, composite functions. And the video for the first half of this section was kind of long, so you'll be relieved that this one is fairly short. Let's look at this example. We're going to go through two examples today. These are word problems in which composite functions are involved. And you'll see that what we learned yesterday does make some more sense when we see it applied to real-life examples. So N is the number of bacteria in a refrigerated food. You know that we put food in the fridge precisely because we want to slow down the multiplication of bacteria in it. Because, you know, bacteria is what causes food to spoil. Putting in the fridge doesn't guarantee that it's going to be fine forever, but it does slow down the rate of spoilage because it slows down the speed at which the bacteria multiply. Alright, so the number of the bacteria in a refrigerated food is given by this function. N of t equals 20t squared minus 80t plus 500, where t is the temperature of the food when it is removed from the refrigerator. Alright, and that function is t of t equals 4t plus 2, where t is the time that has elapsed since the food was removed from the refrigerator. Okay, so if this is the case, then we have to find n of t and tell what that represents. So n of t, this is obviously a composite function. And what I'd like you to do is pause the video, write out what n of t would be, and then use your use your common sense and your logic and put in words what n of t represents and see what you come up with. So pause the video, do that, and then resume. Alright, so n of t equals 20 times the quantity 4t plus 2 squared minus 80 times the quantity 4t plus 2 plus 500. And we can see what happened here is that instead of plugging in a simple variable big T, we plugged in the function spelled out 4t plus 2. Alright, so 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. Now what does it represent? It represents the number of bacteria in a refrigerated food as a function of how much time that food has been removed from the refrigerator. So you see what we did is we put the two things together. And so we're basically combining the functions. We have this composite function so that we give the final result, number of bacteria, as a function of the very basic unit here, which is time. That's our independent variable. And so this is a bridge between number of bacteria and time. And the bridge function is the temperature function. Okay, so this is what it represents. And now let's apply it. After how many hours will there be 2,000 bacteria in the food? Alright, pause the video, do that on your own, and then resume when you have an answer. The answer is 2.2 hours. Now, you should have gotten this simply by setting 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500, setting all that equal to 2,000. Now, if you do that, you set all that equal to 2,000, then you just need to solve for t. And, you know, there is some kind of tedious algebra in all of that. But you should be able to do that by now. And if you're a little bit rusty on your algebra, well, this is a good time to practice. You can practice with this example. If you got the wrong answer, try and do it over again until you get the right answer. But it is t of 2.2 hours. And after 2.2 hours, that is 2.2 hours after the food has been removed from the fridge. After that amount of time, there will be 2,000 bacteria in the food. That's actually not a whole lot of bacteria. Anyway, it doesn't matter. Okay, so the next example we're going to look at is the cost of producing X ovens. So let's say, suppose you run a factory, and one of the things the factory makes is ovens. Well, the cost of producing X ovens is big C X equals 48X plus 1150. So that would be 48 per unit, and then a setup cost of 1150. Now, the number of ovens produced in T hours is X of T equals 40T. So that would mean, they produce 40 ovens per hour. So find C of X of T and tell us what it represents. Pause the video, do that on your own, and then resume when you have an answer. C of X of T equals 48 times 40T plus 1150. We simply put 40T in for X. So that's our composite function. And C of X of T represents the cost of producing ovens as a function of how many hours are spent producing the ovens. Okay, now let's apply it. What will the production cost be after 4 hours? And pause the video, do that on your own, and then resume when you have an answer. And you should have come up with $8,830. $8,830. Here's the classwork. Page 90. Write these numbers down, and we'll see you in class.